Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. You can also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain and the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV or Wednesday Experimenters group. I've got Ron, VK7 WRC, in the studio. Hello, Ron.
Hello, Justin.
And can I just point out, this is our first Wednesday Experimenters group in high definition, full high definition, the whole chain. So it's not just bits of the chain; it's the whole chain. So hopefully you'll see a few improvements and all sorts of improvements like high definition. We can zoom in here and do all sorts of things. But anyway, we'll give you a tour of the studio in a future program. But before I get underway, wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land upon which we are presenting tonight, and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. Now, the reason I've got Ron in the studio is Ron's been weaving a bit of 3D magic. So over to you. Tell us about the problem that you've solved.
Yes. Yeah, well, the problem that I had was I got given a new radio and
Nice.
Vehicle radio. So I needed to come up with a way of mounting it in the car. But the car's a fairly new model car, and I just couldn't get the drill out and to drill holes in there. So I had to come up with a way of attaching this radio into the car without drilling any extra holes, just using existing holes or surfaces. Okay. Yeah, to mount the radio.
Cool.
Yeah.
So what did you come up with?
Yeah, so of course it had to be something 3D printed.
Oh, of course.
And it was a complicated shape because on the side of the, what do you call it, bell housing or the console, centre console.
Centre console.
Yeah, it's got all different curves and everything like that. And I thought, how am I going to design this? Yeah, has that come up?
Well, you want me to head across to, here we go.
Yeah. So
there's the centre console.
Yeah. So that's this is a Holden Trailblazer. And I wanted to put that radio up on the side of the centre console up there.
Now, what radio is that? Just a minute.
Yeah. Is it the Retrievus?
Revitus? Retrievus?
Something.
I don't know how to say that.
Yeah, I don't know either.
Okay.
RT95. It's one that Hayden featured on his channel.
Of course.
And it looked like a really good one. It's UHF, VHF.
Okay.
And I liked it because it was a small size to fit into a small area.
Some nice heat sinking on the side of it as well.
Yeah, and that yellow sticker on there says "Do not touch, gets hot."
Okay,
could
right.
burn your leg.
Right.
No.
Okay. Okay. So you don't need to use the heater in the vehicle.
Yeah. So
Okay.
that was the challenge. Now there's only one bolt hole, and you can see it over to the right hand side there. I took that little plastic screw out just to see what was in behind there, and luckily there's a metal bracket behind it, so that's where it gets all its strength from.
Oh,
there.
okay.
Yeah.
So you've taken the bolt out in that.
Yeah. There was a
picture.
little plastic screw thing that went over the top for dressing, sort of thing.
Okay.
Yeah.
Next photo.
Yeah. So I was using Fusion 360 and the feature where you take a photograph and import the photo into Fusion 360.
Wow.
Which is what I've done.
Okay.
And then I just went around drawing lines, tracing curves and generating circles and all that sort of stuff.
I love that.
So what you see is what you get.
Now, I'm a bit confused. Do you have to tell it some sizes?
You do. When you take the photo and you import it in, you've got to calibrate it.
Yeah, okay.
So I just picked a straight edge. It was actually the one on the top running downwards.
Okay.
I measured it in real life.
Yep.
And then you adjust that in the software. You say from here to here is so many millimeters.
Right.
And then it scales it.
Okay.
I've used this method quite a few times now, and it's worked really, really
Fantastic.
well.
Okay.
Yes.
Okay.
Yeah.
Okay.
So that was the design. Now the anchorage points on the right hand side down the bottom. That's I've put a bolt. A bolt goes through there to hold it.
Okay.
And those three little squares down the bottom, there's the bottom of the center console. The edge stops there.
Yep.
So
Actually, if we go back,
yeah,
you'll
you can see.
the...
Yeah, and that was about 2 millimeters wide.
Okay.
There.
Okay.
So the design of my 3D print, I recessed that in there because it was too wide for a clip to go over the whole thing.
Okay.
Especially the clips that I was using.
Yeah. Okay.
And the other mounting point was right up on the top. You'll probably see it as we go a bit further. On the top left-hand corner there, I stopped it there because it was easier to print that part.
Yep.
Because I've got a hook thing that goes around that holds it steady at the top.
Okay.
And it was just going to be too difficult. I would have had to use supports all over the place and all that.
Okay.
It was just easier to print something else separately.
Okay.
And then just attach it with a couple of bolts.
Okay. Okay. Next one.
Yep. Right, and that's on the bed of the printer as displayed in the slicer that I use.
Okay.
Yeah, the slicing program that I use.
Okay.
Yeah,
So that's how it will print it.
yes, that's how it did print. Yeah,
Okay,
yeah, and you can see on the front edge down on the bottom left, there's two little holes there, and they're threaded. So that's one of the good things I like with Fusion 360. You tell it the bolt like M5, and you say this is a threaded bolt, and it's the depth and all that, and it just does it for you.
So it puts the thread in and everything.
Yeah,
Oh, I
it just
love it.
puts it in there, and I printed it in PETG, because the inside temperature of the car would get a little bit warm. PLA would just melt, so PETG withstands temperature a bit better.
Okay.
And it's nice and strong, and the thread, it just screws into there and holds it really well.
I love it.
Yeah, recessed bolt holes so that because that's the inside part that goes up against the center console.
Okay.
Yeah,
Okay.
so I recessed it so the bolts that hold the bracket, they're not protruding out and scratching on the plastic.
Yeah. Okay.
Yeah.
Fantastic. All right. Now. Oh,
Yeah.
the actual item.
Yeah, and so that's with that bracket fitted on the left-hand side.
Okay.
And I glued some felt on it, so I didn't want the sort of
The console scratched.
getting scratched if it was
yeah.
to be moving around or anything like that. So
Okay.
it's all felt lined just to protect the plastic on the
Fantastic.
console. Over on the right-hand side was where the bolt goes, and there was some funny angles going on there and everything, which I ended up designing.
Okay, and where the bolt actually goes in, there is a sort of a protrusion that fits into the little recessed
The
hole.
exists, if you want to go back a couple of slides, you can see that if you wanted to.
Okay.
Yeah, right back to the
Oh, yeah. No, okay.
And there you can see that on the
Yeah.
right-hand side there.
Yep.
Yeah.
Okay. Wow. Okay.
And that's just flipped
Oh, that's
over.
the other side.
And
Okay.
that's the actual bracket that holds the radio on.
Okay.
Yeah.
Okay. And the nuts go into that little recessed area. On
Yeah,
the
the
other
bolt
side,
heads
so.
on the other side. They're the nuts on the
Oh,
top.
okay.
Yeah.
Oh, fantastic. Okay.
And if you have a look at the next one, and that's it in place, and you can
Well, there you go. Whoops.
you can see the bolt on the right, the little arm thing going around the top, all felt around that so it doesn't scratch it.
Yep.
And the 3 clips down the bottom, they're paper clips. That you.
I love it. Yes.
So it's the right thickness
Yeah.
for the.
And they're removable paper clips too.
Yes.
They you pull them down and they open up and then
That's correct.
Yeah. They're great.
And that's basically just to stop it from flapping side to side.
Yeah,
So it's
okay.
being held from the top and the bottom. And
Okay.
it's quite rigid there and
Okay.
it fits quite well. Yeah, I think
I love it.
maybe one more photo,
one
is
more?
it? And
With the
no,
radio.
2 more. Yeah, and that's the radio installed
Yep.
on it.
Okay.
Yeah.
And all the wiring sort of disappears into the center
Yeah.
console, so
Yeah.
that's really good.
Yeah.
And the hot surface is on the other side.
it is.
It is on the inside
So
side.
Hopefully
So,
it won't get too hot.
well,
but there is a
depends
bit
on
of a
how
gap.
much you talk.
There is a bit of a gap. Yeah. It's mostly
Yeah.
listening.
Okay.
But,
And I like that because that means the speaker is actually on the outside.
Hmm.
It's actually that's good.
Yeah.
That's very good.
And then the last photo is looking down on it. So it's,
Oh, look at this.
that's how
So
it's,
that's how the display.
yeah, and I've got the. I think with this model you can actually flip the display around. But,
okay.
the way it
Okay.
is at the moment, the display is. If you turn your head a bit to the left, you can see it. So it's,
As you're driving
Yeah.
down the road. Yeah.
yeah,
Okay.
but this one can be flipped
Okay.
apparently. Yeah.
Oh, fantastic. That is excellent. Now, and you've got the actual item here.
Yes.
So what I can do is some tricky stuff here, and we'll just do some tricky. Oh, and that's reversed. I've got to think in reverse here.
So that's the way that I see it in the car.
Excellent.
Yeah. So the
Just
paper.
focus. It will focus in a short period of time.
Well, if I go this way.
Oh, there we go. Yeah.
there we go.
No,
Yeah.
there we go.
Right.
There we go.
So there's the paper clips on the bottom.
I love it.
Yeah.
Just let me zoom in right in here, because so you can actually see these paper clips. They're a great use of stationery.
Yeah.
There we go. So they pull off. If you pull them down, they unclip,
Yeah.
and then you push them back on again, and they clip. And I love it.
And that's all the felt lined on the, so nothing gets scratched. On that.
I love it.
Yeah.
That is a great use of 3D printing and design, and I absolutely love the whole thing of now, if I push this, watch this.
Automatically resets.
If I automatically resets. Now, I didn't know you could do that with Fusion 360, where you can take the photo and then calibrate the photo.
Yes.
Because that is so that is wonderful, because if you've got a really awkward place that you're trying to fit something into, that's off the show. I love it. I love it. Well, that's excellent. So, what antenna are you using?
It's
And where's it mounted?
Yeah, I didn't get a photo of it.
Okay.
It's a diamond one.
Okay, yes.
Not sure of the model, but it's UHF VHF.
SG something 7 something something something.
Yeah. It's and I just put it on yesterday, and I thought, I'm going to have to tune this. It's got those little adjustable tuning things on it.
Ah, okay. Yes.
And
here we go. Have we got the technology for you? Oh, okay.
yeah,
You have a now.
and then a VNA.
Let me find the cursor here. Where is the cursor? There it is.
Yeah.
Okay.
All right. So have a look. So you got the VHF on the left. I set it to 144 megahertz.
Okay.
And have a
Over
look at the SWR up there, 1.17. And that's with no tuning. I just put it on, and
I love it.
And
then we go up the UHF end.
yeah, 440, and it's
That's quite flat actually, upwards.
1.09.
Yeah.
So that's not bad. I haven't transmitted through it yet, but
I think you won't have any problems transmitting through that. So there you go.
So where is it mounted? I got a nudge bar installed on the front of the car, and unfortunately, the nudge bar is quite low. So you got the bonnet. It's not a bull bar. It doesn't come up to the bonnet height.
Okay.
So there's a fairly long drop from, and I thought, well, it's attaching it down there is not going to be any good.
No.
So I tried all sorts of things. You can get, I think they call them riser things, bases or whatever. Yeah. And I didn't have any luck sourcing one, so I thought, I'll make my own.
Okay.
I didn't 3D print it. I just got a bit of conduit, and I was sort of making like a flower pot. So I put it on the top, and I just tried it. The SWR wasn't real good. So with the flower pot, I started putting a few turns around it with the coax. So I tried it at the top, right at the bottom of the antenna, wasn't much good. Tried it in the middle, wasn't much good. So I put it right down the bottom, and I got it fairly good. I think the SWR is about 2.5. It resembled that. 2.5 on VHF and about 1.5 on UHF. I thought, wow, that's almost doable. But they sell these little clamps or brackets where you hook it to where your bonnet hinges. Yeah. You take 2 bolts out there, put it on there so it's up towards the windscreen. And I did buy one of them. I thought, if all fails, I'll revert to that.
Okay, plan B.
I thought, so I spent a bit of time with experimenting. Well, that's what it's all about. Yeah. With the flower pot design type thing with the antenna. And I thought, well, I'll just try it. I've got it, so I'll just try it. So I bolted it on there, and that's how it came out. So I thought, I'm using that one.
Well, truly, that's excellent.
Yeah.
That is really, really good. Okay. Oh, that's fantastic, Ron.
Yeah.
That's excellent. And great use of Fusion 360. Great use of... it was PET-G?
PET-G.
PET-G.
Or PGG. PGG or PET-G. Yeah.
And so temperature stable.
Yeah, it can withstand higher temperatures without
Do you actually
melting.
Have to print that at a higher temperature?
You do. Yes.
Okay.
Yes. I think it was like about 235 degrees Celsius.
Okay.
Printing. So is what my settings were.
Okay.
And it was Prusa slicer was the slicer that I used. I couldn't figure that before.
Yeah. Which we heard about at the 3D printing forum.
I quite like that one.
Okay. Well, that is absolutely fantastic. So, now on to slightly different topic. We're going to wind back from 3D printing and Fusion 360 back to the almost the 17th century, but not quite. The 18th century, the 19th century. That's better. Yeah. The 1800s. So now Ron came to me quite a number of months ago and said that a friend of his had given him some equipment, which was... My eyes lit up when Ron pulled it out of the bag, because it... and in fact, what we'll do here... We'll come... It's in view there, but we'll we'll actually get a bit of a close-up view here, because this is worth it, because there is absolutely beautiful piece of engineering here. Now, what I'll do is give you that before I forget. So, the thing that Ron brought in was, and the telegraphy aficionados in our midst will instantly recognise this as a relay, what they call a telegraphy relay. Very simple. It's a solenoid. So 2 coils of wire in here, wound on a core. There is a little arm that moves, a ferrous metal arm, can I just say, because it wouldn't work with aluminium, and aluminium wasn't available back in these days. There are 2 contacts up here, underneath here, that you can adjust. You can see the screws here, and those contacts then go to here. So what you've got is your telegraphy line coming in here, and your other line that is going out in the other direction coming in here. So anything that is coming down the line, in either direction, will be actuating the solenoid.
That's in series.
Correct. And in fact, I'll show you some pictures of the circuit in a sec. But what it then does is give this telegraphy office. They then connect up to here to these contacts. The sound, what they call a sounder. Now, a sounder is literally just a relay, and I'll show you an example of a sounder in a sec. A relay that is usually has a sort of a large speaker type soundboard box that it sits in, and it just amplifies the relay. And so when I was thinking about this, I went, okay. So I worked out what voltage this particular relay operated on, and we're talking about 6 volts. You know, we're not actually talking about very high voltages here. And so I got my LiPo battery out here. It's slightly more upmarket and slightly later. And if you can see here, hang on. You can see that as I'm touching the wire to the terminal here, the solenoid working, and it's the little contact up here is being made and broken. Now, what I then did was think, and I'll bring this up a slight amount. That's it. I then got the terminal which would normally go to the sounder going through a bunch of batteries here. Now, I need this number of LiPo batteries because this is a higher voltage relay.
12 volt.
It's effectively 12 volt. Now this is would you believe this is a relay, and this is an actuator arm out of a printer. So this is a relay that they use in a printer. But the thing I liked about it was it had this wonderful little arm on it that can tap away on a piece of wood. So if I hold this sideways so you can actually see it actuating, and you can see that it's completing the circuit, and then the current from the batteries is flowing through the relay and it's actuating as well. And so what I'm looking at doing with this is building this into a box, a sounder box, and I'll show you an example of a sounder box in a sec, and rigging this up so that the LiPo batteries are not visible because they're slightly more modern than the whole arrangement, and mounting this on a nice board, a varnish board, and all of this sort of stuff, so that there is a bit of a demonstrator circuit. So I'll now show you the circuit. So sorry about that. That was just a big crunch. So this is the relay. So how does telegraphy work? You've got, this is the relay that we're talking about here. So you can see this is your telegraph line, comes in from one direction, goes through. Now in this particular case, they've got a relay station, so a telegraphy station going to another telegraphy station. In a lot of cases, this would be a telegraphy station in the middle of a line. So, but okay, just bear with me. So this is the relay here. In most cases, this would continue on and go off in the other direction for the other line. And all that would happen was the line would be going through the solenoid on the relay and going straight through. And unless you actually had a telegraphy station where you actually wanted to do telegraphy at the telegraphy station, so that it was like a relay station or something like that, where it was receiving a message, then it would retransmit that message, or you're just listening to what's going past, so any sort of messages. But so it goes through the relay. This is the relay. It has a contact here. There's a separate little local circuit which is the battery going through a sounder. So this is just another relay that's pulling some contacts down and making a noise. And you've got this on one end and exactly the same thing in mirror on the other end. So now there is investigation. Oh, okay. Here it is. Here's exactly what I'm talking about. So you've got the main line coming in, going through the relay. It goes through your key, and then goes out the other line. Now, one of the things that a lot of keys have is a shorting bar. So there's a little arm on here which shorts out the two contacts, and the reason you need that is when you're not wanting to use Morse code on the line, you have to short it out so that it goes through all the way through, so that the people further down the line are actually getting the same message. But you can see, comes in, goes through the relay, through the key. If it's shorting bars there, it goes straight through the key and back out again. And then on the contacts that are here, it goes to a little local circuit, which is a local battery and the sounder. And that's literally what a telegraph office looked like in, the mid to late 1800s. And there were hundreds of thousands of these around the place. So, now, I'll show you an example. Let's see how we go with this. Let me just get in here. I went to to Bendigo a couple of weekends ago, where to the WIA AGM, and on the Sunday, the Bendigo Amateur Radio and Electronics Club, Barrick, put on a technology fest, and one of the stands at the technology fest was a telegraphy and old telephone stand. And so they had a key connected up to a power supply, and this is a little meter, and then they had a sounder. Now, this is what a sounder looks like. It is literally a little relay. It's got a set of contacts. It's got usually quite a large arm that bangs down on the no. This is one of my favourite places. Bangs down on the rest of the frame here, and you can see it's mounted into a box that just amplifies the sound. Now, if I turn the sound up here, I'm not getting anything. Why am I not getting anything? Oh well. Anyway, why am I not getting anything?
Bluetooth connected to something.
Yeah, maybe it is. Anyway,
that's what always happens to me.
Oh, now let's get rid of everything. No. Sorry, just bear with me. Bluetooth.
Turn it off.
Vivo. No. Okay. Let me just turn that off. You're right, Ron. Let's go with everything. Absolutely nothing. Anyway, you can hear it clicking away like you could hear the relay clicking away, and the sounder actually amplifies that noise. And so
passively. So
what I'm looking at doing is mounting that relay into some sort of box that just amplifies the clicking of the relay. One of the things that you've got to come to grips with, if you're used to tone Morse code, it's quite different.
Yeah.
It is really... I know why.
There we go.
I had it on silent.
Yeah.
So let's transition that again.
Yeah, it would be different to if you're used to tone.
Correct.
Yeah.
Because what you're listening to is the distance between the clicks to work out whether it's a dot or a dash.
Yeah.
But that's what telegraphy offices used to sound like. And if you've been to one that I've been to where they operate sounders is up at Alice Springs. If you ever go through Alice Springs, go to Alice's Spring, which is what named Alice Springs. And Alice's Spring is where the telegraphy office is. So that was the line that went from Adelaide to Darwin. Single piece of soft iron core wire on insulators that went thousands of kilometres. So and many telegraphy stations along the way. They could only go a certain distance before they had to actually have a relay station where they received it and then they retransmitted it. Because they couldn't. If you had to do the thousands of kilometres, you'd have to put thousands of volts in one end.
It's interesting
to get nothing out the other end.
I worked at Catherine.
Okay, yeah. Of course, the RAF base
Tyndall, and we had a fibre optic between there and Darwin, and it could only go a certain distance before they had to reboost it.
Well,
so the same thing. So all this new technology, fibre optic cable, and they had to keep boosting it along the way, like they would have to with
which
that.
is a real issue undersea, because they actually have to embed the amplifiers in the cable and make them waterproof and all of that sort of stuff, and be able to power them through other means and all sorts of stuff. Yeah. And so have a think about that.
It's just amazing.
That's the sounder arrangement. Once I get that all we're hoping to get your friend into
the bloke who
into the studio and then demonstrate it properly. So
he'll have a good story about it as well. Which
and truly,
yeah.
All right. Now the other thing, actually we'll leave the other thing. We'll leave the other thing because it's in the.
Okay.
We'll leave that as a special.
It's a secret.
As a secret, yeah. Don't. Now, a question for our viewers. Now, hello. Now, let me acknowledge who's on the stream and not on the stream. We've got Bronson the Cat. We've got Peter VK3MV. Hello Peter. Hello Bronson. We've got David VK7DBX. Damn Justin, I thought you were in the 20s. The HD feed reveals the truth. Oh yeah, sorry about that, Bronson. Yeah. You can see every friggin' wrinkle and grey hair. Greetings TW and WRC. That's from Jim. That's from Jim. It's Joe Z, who's in VK3 right at the moment. We've got Murray, VK7ZMS. User pool noodle Ron.
User pool noodle.
Yes, okay, I understand that comment, Murray. We've got Matt, VK7 MAT. We've got Mark. We've got Hayden as well, who's next door. Pool noodles don't melt either, so there you go. I'm looking now, Mark. I'm looking for a readout box for my FT7. If anyone can help, please. So, okay, he's putting it out there. We've got Stephen, who's VK3 double TF. Now, I think Stephen, if you're still on there, I have actually joined the ATV Discord, and I intend to put some content up there and bits and pieces on what we're doing and our new studio and bits and pieces. So there you go. Now Yoni, far out, beautiful cheers. We've got Ron. Hello Ron, VK7RM. And we've got John, M0XJA, a UK interloper. Well, you're most welcome, John. You are absolutely most welcome. So good stuff, and I'll periodically get back to that. So the next thing is, how many people went to the Anzac Day Parade? Did you go to the Anzac Day Parade?
No.
Oh, come on, Ron. Now, one of the standout highlights for me from the Anzac Day Parade was the very first group in the marching, because there is a real hierarchy of marching where everybody marches in a particular place in the parade, which relates to the conflict and relates to the all these things. One of the key things about the parade this year was this Royal Signal Corps was the very first group. And the reason the Royal Signal Corps were the very first group was because it is the centenary of the Royal Australian Corps of Signals. Now, one of the things that came out in April, the Royal Australian Mint came out with a special coin, which I'll go into in a sec, a special dollar coin, which it celebrates the centenary of the Royal Australian Corps of Signals. So if I turn this over, now the first thing I noticed was there's a misprint.
Might be worth a bit.
It's the 2025 $1 uncirculated coin. So this might be as any flaws. Yep. We've got King Charles on the coin. So that's but it goes into all about the signal core, and I've got a little bit I was going to read out because it's a little bit special, and I'll then go into, because there is a code that you need to decode on the coin.
Yeah, I heard about this. Yeah.
So now it was released in April. So I put in, when it was released, I put in for two of them. So because there's only 50,000 of them that have been printed, so I put in for a couple of them. For 100 years, the Royal Australian Corps of Signals has been at the forefront of military communications, ensuring a swift and secure transfer of information across the battlefield and beyond. Since its establishment in 1925, the Corps has played a vital role in every major Australian military mission, pioneering advances in electronic warfare, cyber operations, and cutting-edge military technology. So the coin and the design on the coin, and in fact, I know what I can do. I took a close-up of the coin because I was trying to work out what the code was. This is good. Okay, so we'll. If I can get this, we're battling the put that there. That's better. So, this is the coin. Now the design is right in the center is Mercury, so it's the Greek god of communication. Stands on a globe symbolizing the core, the national and global reach in military communication. It holds a lightning bolt up the top, signifying rapid communication, while the second bolt, which is down here, beneath his foot, reinforces the Corps' motto, which is Certa Cito, which is swift and sure. And it says Certa and Cito, and then 1925 and 2025 here. Now, in the background here is a whole lot of binary and Morse code. So it's the challenge has been put out to anyone to try and decode the code. Now, there is.
I think I saw you had some ones and zeros
What
there.
I've done here is, this is the left and right of Mercury with my
Microscope.
my head magnifiers. I have gone through and written down in much more understandable terms the Morse code, which I've decoded. Most of the Morse code is Certa Cito, so the actual motto. And then I have been trying to, using a ASCII chart for the binary.
Oh, did they use ASCII back then, or was it EBCDIC?
I'm not sure. I'm not sure. So I haven't got to the point where I'm starting to find little decodes. But anyway, but. Good point.
Yeah, because I think it's 5 characters. 5.
Correct.
5 things, yeah.
And there are 5 character blocks.
Yeah.
Oh, that's 6.
Yeah.
But anyway, they're right around the edges of where the image is. There's a bit of interpretation required of whether it's a 1 or a 0 or it's a dot or a dash or whatever else. So
yeah.
Anyway, I'm working my way through the coin and the trying to decode what it actually says, and they talk about this. The hidden code. So the coin design includes Morse and binary code, spelling out Certa Cito. This visually links the core's historical roots, Morse code, with its modern role in electronic warfare and cyber operations, the binary code. So the binary code could actually be ASCII or could be something, or it could be in code. So the Australian, the ASD, the Signals Directorate, the Australian Signals Directorate had a coin a couple of years ago where there was a code, an encrypted code on the coin. And apparently it only took a 14-year-old a half a day or something after it was released, and it was they decoded it. But anyway, so today there's a comment made here. There were more than 100,000 signallers have served in the Corps since World War One, when it started. And today the Corps has a workforce of approximately 3,000 trained personnel, with an average of 300 personnel joining the Corps each year. So I thought that was pretty good.
Yeah.
It's still a valid career option, well and truly. So there are more than 300,000 family members and descendants of those who have served in the Royal Australian Corps of Signals. So there you go. I just thought I'd show, because it does have a bit of a linkage to what amateur radio is all about. And in World War II, a lot of the radio operators that started at the beginning of World War II were amateur radio operators, because it was a ready workforce that they could actually pull in. So a lot of amateur radio operators went on to become signals operators. In a variety of conflicts, so there you go. But anyway, a bit of fun, a bit of fun. Now, I'll just go to make sure that we're not missing comments here. Great to hear the Discord. Interesting. Proper crack the code. Okay, you're cool. Yes, Sean. Hello, Sean. So VK7 WTF. Great call sign. Love it. ASCII, Ebsidic or Bordeaux. Well, got choice there.
Yeah.
And in fact, I think on my little ASCII chart, there's binary, octal or hex. Now, it could be octal. Wouldn't be hex because it's zeros and ones. Yeah. But who knows? Who knows? So anyway, that's a bit of fun and coins, and I think the coins are still available. So if you're interested, they are $17.50, I think, $17.50, something like that, plus shipping from the Royal Australian Mint. So there you go. Now, Fred's book. No, in here. So, many people may have learnt their standard and advanced license through Fred Swainston's book, so VK3 DAC. He's also got a VK4 call sign. And Fred's handbook, which I think's up to edition 6 these days, is one of the ones we recommend for people who want to move on to standard and advanced operation. And Fred has just come out, literally within the last month, with a new book. And the book is Applied Mathematics for Radio Operators. Now, I think this has come out of there is a mathematics section in his book, but a lot of people come into this later in life and haven't used mathematics since they were at school and bits and pieces. So what Fred's done is put together applied mathematics for radio operators, and this follows the Harrick and CEPT syllabus inclusions for the advanced operators. So if you're wanting to get your head around mathematics again whilst you're studying, this is a great. It's only small. It's only quite thin. How many pages? There are 97 pages, so not very long at all. It goes through. And I'll just go through a few of the headings out of the book. Obviously, starts off with the really basic stuff: the number system, basic arithmetic, fractions, radical scripts, the order that you do calculations in, approximation, powers of 10. Formula transposition, ratios, formula sheets, etc., and then application of formulas at each of the qualification levels. So that's really handy. Then goes into formulas in the syllabus, graphs, implied and derived examinable formulas, Greek symbols, and then a whole section on examples, questions, and workings, and then the answers to those workings as you go through. So lots of examples, lots of things that you potentially might come across in the exam. Lots of worked examples. Can I just say, and really easy to understand. So if you want to get your head around the applied mathematics that's involved, it is also, you get a little SD card on this, which is the book and all of the worked examples and a whole lot of other bits and pieces in there. So anyway, Applied Mathematics for Radio Operators, first edition, which has just come out literally from Fred Swainston. So yeah. We're poring over this right at the moment with a view to our learning management system that we're coming up with. So there'll be certainly a mathematics section of that, and we'll potentially use some of the worked examples out of here, with due credit, obviously. Yeah, really excellent book. If you want to get your head around mathematics again, do yourself a favour. I think it's something like about $25. I think it's something like $25, and that includes shipping.
Right.
So I'll confirm that and put it in the video description. But anyway, there you go. Now, just to finish off, how are we going for time? Okay, we got 15 or just under it. Okay, I mentioned earlier, now, hang on. How did I find this channel? Yeah, okay, well, there you go, Yoni. It's amateur radio. It's all about amateur radio. And this is the Radio and Electronics Association of Southern Tasmania. So, okay, a couple of weekends ago, I went to Bendigo, as I mentioned. One of the things I did on the Saturday morning before the AGM was work out what to do in Bendigo. Now, can I just say, Bendigo is one of these places where you walk around Bendigo and it's a bit like Launceston, if you know Launceston. Lots of really old buildings in Launceston and Bendigo, but lots of really big old Gothic type buildings where it's got that real feel that there was a lot of money in the past. It's that sort of thing. And I then went down the road to what's called the Central Deborah mine. Now, this is actually it was a working mine that was about to be closed down, and the Bendigo City Council had the foresight to buy it. Now, it's literally, it's about a 10-minute walk from the CBD of Bendigo. Oh. So it's actually in the city of Bendigo. You can see the big poppet head above the skyline and all of that sort of stuff. Now, this mine was about to be closed down because it was not profitable anymore. It has still got a lot of gold in it, but it's not profitable to get the gold out. That's what this is about. But what they've done is set it up as a tourist attraction, and you actually go. There's all of the workings at the top, but then you go down 61 metres to one of the levels. They take you down there, you put on your hard hat, you got your light, all of that sort of stuff, and your enclosed shoes and all that sort of stuff. and they take you through a little safety briefing, and then they take you underground, and they go round to a variety of areas underground, and they tell you all about gold mining. And this mine was open from the turn of the century. So this is the turn of the 20th century.
The last one.
The last century, up until 1954, I think it was. And so it has seen quite a few changes in technology and all sorts of stuff. But one of the things that they do, now let me bring up, because I've got some great pictures and video. So one of the things you were allowed to do was take as many pictures as you like underground. I'll get to that. Okay, that'll do. Let me just go to... That's better. We just went out into our club rooms, so apologies for that. We've got the document camera. Okay, now let me just get my act together here, and let's zoom in here. So, come on. That's better.
There you go.
So here we have our guide who's underground, and he's about to demonstrate. This is one of the drilling rigs, and this is called a Widowmaker. So, and he goes through This is the old one, and then there is a much later one, which was also. That was the Widowmaker, because that had a lot of dust associated with it, so you ended up with silicosis. And then you went across to this one, which actually uses water and compressed air, and he then takes you through and turns it on.
And that one's got hearing protection.
Well, he's got hearing protection. Nobody else does. We're all sticking our fingers in our ears.
Yeah.
But it actually is bloody noisy. So he then takes you, as he takes you around, he tells you about all the different aspects. This particular area that he was talking about was talking about how they blast. So they drill. The drills are for drilling the holes, which they fill with explosives, and then they trigger these explosives, and they trigger them in particular patterns. And they've got a little simulator. And you can see he's talking about it here. This is underground. You can see all of everybody's headlamp all over the place. And he does a little demonstration, and you can see with little lights. There we go, in the middle. And these explosions slowly come out further and further and further until they're right on the outside. So
gives it room to clear.
Oh no, well and truly.
So
and this particular point here, you can see there's a little hole that they drill in, which releases the pressure.
Yeah.
And you can see it slowly coming out further and further. And it's got little sound effects, not quite as loud as the drill, but anyway. So really well put together. Really, really well put together. And he talks about this is mechanized mining, maps of the workings underneath Bendigo, which is just off the show. Now the thing I wanted to show you earlier, here we go. There is also a wall which is behind glass. Which
see the gold in it.
Has gold in it. Now, you'll notice there is this dirty quartz, and the dirty quartz is exactly what they're looking for, because the dirty quartz actually has flecks of gold in it. That's what makes it dirty. So it's this little bit that they're mining and getting rid of all of this other crap to get to those little reefs of gold, of quartz, to get the gold out. So, and there's still, as he points out, there is still gold. There is well and truly still gold in the mine. It's just not viable to mine it. Now, I'll just mention Bendigo. This is one little fact about Bendigo that I didn't know about. There was more gold pulled out of Bendigo in the gold rush than all of the other gold mines in Victoria put together.
Huh.
And it amounted to 700,000 kilograms of gold, which in today's terms is about $80 billion.
Wow.
Like you have a look. They have a little chart. They have a little chart up on the wall in the mine, which has got the amount of gold pulled out of mines, areas in Victoria. Bendigo's like this. Everybody else is sort of down here. And you put all of them together and it doesn't amount to what's been pulled out of Bendigo. So you can understand why there's so much money in Bendigo at the time. So, but well worth a look if you're in Bendigo. The Central Deborah gold mine, really, I think it was $25 or $35 for the tour. The tour takes about 2 hours. So, and then you can look at all the stuff on the surface and all of that sort of stuff. But anyway, there you go. That's not amateur radio at all. It's a bit of promotion of Bendigo. So I'll take my cut later. Now, finish off. Okay. When I was at the AGM. This is amateur radio related.
You better talk about that.
Yeah, I better talk about this. Dale Hughes, VK1 DSH, who is currently in Geneva right at the moment, attending the ITU meetings around all of their working groups. Dale is the chair of Working Group 5A on amateur and amateur satellite service. So, and Dale let me know that there was a report that was being put into the radio communication study groups meeting that was happening now. It's happening right now. And in the report on amateur and amateur satellite service, down under the scientific, educational and technological activities is the biennial Hamicon Amateur Radio Conference was held at the University of Tasmania, Australia in November 2024 and focused on innovation in amateur radio. The event showcased a compelling lineup of keynote speakers and diverse presenters, including academics and amateur radio experimenters, exploring themes like space weather analysis, innovation process, propagation experiments, programming tools, electromagnetic radiation safety, microwave transceiver designs, among other topics. The event was hosted by the Radio and Electronics Association Southern Tasmania and included a visit to the Great River Museum and the Mount Pleasant Radio Telescope. So that is going into the ITU Radio Study Group number 5A, Working Group number 5A, and features a little bit of Tasmania.
Yeah.
So very happy about that. Very, very happy about that. Now we'll finish off with what's coming up. We've got a standard advanced and regulations assessment day on the 31st of May. Next week is another one of these. Is a Wednesday experimenters group meeting, presentation in here. So you'll have a whole bucket load of other things. The next of Ron's 3D printing creations. June the 2nd, so in a couple of weeks' time, and in fact Peter VK3MV is on in the chat. I noticed we're doing a class license Q&A, so it's a bit of a short presentation on the class license and what it's all about, and then taking questions. So bring along all your questions. It will be streamed, so you can drop some questions into the chat, and we will hopefully be able to answer them. A reminder that from June the 9th to June the 16th, so Monday to Monday, the club rooms will actually be closed because we're having the ceilings replaced. So, and possibly the switchboard replaced as well, given today's little exercise. And then on June the 18th, so a week later than what it normally is, Forum Night, Essential Shack Test Equipment. So there you go. So that's your blooming lot for tonight. So this has been the Radio and Electronics Association of Southern Tasmania with our Wednesday Experimenters Night broadcast. And this is VK7 OTC wishing you 73 and...
Yep, 73s.
VK7 WRC 73. So we'll catch you next time. Cheers.
Okay.